بسم الله الرحمن الرحيم. بديكم النهارده تاني محاضرة في الكلينيكال اوفثالمولوجي على الاكسترا اوكلر ماسلز. انا دكتور مجدي موسى، استاذ ورئيس قسم طب جراحة العين في طب طنطا. الاكسترا اوكلر ماسل من الحاجات المهمة جدا ولازم نستوعبها كويس ونقدر نفهم ازاي العضلات بتاعت العين بتتحرك. البلان اوف كوندكشن في this clinical round عبارة عن short introduction وبعدين explanation of the basic principle of the extraocular muscle وبعدين في فيديو demonstrating with discussion how to examine the extraocular muscle and the foria and tropia. Time of practice at the end was 15 minutes. Let's start by the extraocular muscles. In the eye we have 6 extraocular muscles, 4 recti, superior, inferior, medial, and lateral recti. Each muscle called rectus, medial rectus, lateral rectus. And we have plural, it's called recti. And we have 2 oblique muscles, superior and inferior oblique. That's why when we say 6 cardinal direction, we have unilateral 6 cardinal direction because we have 6 muscles. What are the nerve supply of these muscles? Lateral rectus is supplied by separate nerve, which is the 6th cranial nerve we call abducens. The superior oblique has the 4th cranial nerve to supply, which is called petroclear, and all the other muscles are supplied by the 3rd cranial nerve. As we see in the picture on the right side, we can see that the 3rd cranial nerve supplying the superior rectus, medial rectus, inferior rectus, and inferior oblique. And the other 2 muscles supplied separately by their own nerves. This picture has to be understood clearly because we have to explain everything in this picture to understand the movement of the muscle after that. We said 4 recti and 2 obliques. Look at this. This is the superior rectus. We have a cut section through the roof. We remove the roof of the skull and we look from above. So this is the superior rectus you can see here, the one up there, and it has a parallel to it down the globe is the inferior rectus. And we have 2 other medial and lateral recti and 2 obliques. Look at the recti and look at the obliques. The recti are inserted, all of them are inserted anterior to the equator. And this is the equator, a line dividing the eye into 2 halves. We call it the equator, خط الاستواء اللي قاسم العين بالنص بالظبط. The muscles inserted anterior to the equator are the recti, superior, inferior, medial, and lateral rectus. The superior and inferior recti inserted anterior to the equator, so when they move, they bring the eye up, superior up, inferior down. The obliques, they inserted behind the equator, so when they contract, they pull the eye down, the superior oblique. It's called superior, but it pulls the eye down. The inferior oblique pulls the eye up. So each muscle against its name, superior pulls the eye down, the obliques, and the inferior pulls the eye up. On the reverse, the superior and inferior recti acts at their name. Superior rectus will bring up superiorly the eye, and the inferior rectus will bring it inferior. This is because of the insertion of this recti. Look again, we have 2 axes in here. The visual axis or the optical axis, which passes through the eye from the anterior to the posterior, through the cornea, through the lens, back to the fovea. So it is the optical axis. How about the orbital axis? Because the eye is inside the orbit. Look at the orbital axis. The orbital axis is having a 23 degree with the optical axis. So they are not parallel. They are crossing each other. And look at the both orbits here in the picture on the left side. Both orbits like a pyramid where the apex is in the back and the base is in the front. And the eye is inside this orbit. It is not parallel to the orbital axis. It has its own visual axis. And the visual axis is not parallel to the optical axis. And depending on this, we will speak about the axis where the eye goes around. To describe any eye motion, we need to define what axes we have. Fixed axes, there is one called x-axis, which the eye moves around it nasally and temporally. And then the y-axis, where the eye moves anteriorly and posteriorly. And then the z-axis, where the eye moves superior and inferior. These axes intersect at the center of rotation, and where is this center? It's a fixed point defined 3.5 millimeter behind the cornea, inside the vitreous cavity. Let's start with the medial and lateral recti, or medial rectus and lateral rectus muscles. the medial rectus, as we see in the figure here, it's in the medial side of the globe, and when it contracts, it moves the globe medially. That's we called adduction. The lateral rectus on contraction moves the eye laterally, which is called abduction. So these are two terms: medial adduction, lateral abduction. And this when the muscle contracts. Let's go to the superior rectus. In the primary position, we say that the superior rectus muscle has its axis is not parallel to the visual axis. The superior rectus muscle has 23-degree angle with the visual axis, but the superior rectus axis is parallel to the orbital axis. So they are not parallel to each other. The superior rectus is not parallel to the direction of the globe. So look at the picture, the next picture. So this is the primary position of the eye. If the muscle contracts, it will do subsidiary action. The main action of the superior rectus muscle will be when the eye moves laterally. So the visual and the orbital axis will be the same. They will be on the same line as the picture in the middle. So when the globe is abducted, moved laterally toward the temple to 23 degrees, the visual and orbital axis coincide. So at this time, when the superior rectus contracts, it's a pure elevator. So this is where we test only the superior rectus. So we have to move the eye laterally to test the superior rectus, and they call it the only elevator in abduction. When the eye moves laterally, the only thing which can elevate the eye is the superior rectus. What are the subsidiary actions? If the globe was adducted, when the eye in the primary position and the superior rectus contract, it will adduct the globe. So the globe, when adducted to 67 degrees, the angle between the visual and the orbital axis will be 90 degrees. They will be perpendicular to each other. At this moment, if the superior rectus contract, it acts as a pure entorter, which is rotating the globe inwards around the anteroposterior axis. And here's a picture where we removed all the muscle and only leaving the superior rectus muscle. Look at the primary position in the middle. When the eye moves and the superior rectus contracts, it will move the eye nasally. Look at the picture on the left side, the end of the picture. The eye moves nasally to 67 degrees. In this way, it will be entorting the globe. Look at the picture on the right side. When the eye moves laterally, 23 degrees, both axes will be parallel. Contraction of the superior rectus at this time will cause elevation. And why elevation? Because the insertion is anterior to the equator. By the way, all the recti muscles are originating from the tendinous ring around the optic canal at the back of the orbit. You have that in the anatomy, except that the inferior rectus muscle, which is the inferior oblique muscle, which arises from the floor of the orbit. This is the superior rectus muscle, and this is what I was saying. In the primary position, the muscle has 23-degree angle with the optical axis. When the eye moves laterally, the optic and the orbital axis or the muscle axis will be coinciding, so it will work as elevator. When the eye moves nasally, the superior rectus muscle will entort the eye, and this is explained this. The inferior rectus muscle. Let's go to the inferior rectus muscle. As we said, when the globe is abducted, the same thing. 23 degrees, the visual and orbital axis coincide, and it will be pure depressor. So the inferior rectus will depress the globe or move it down. Then if the globe were abducted inside, move to the nose, 67 degrees, the angle again between the visual and orbital axis will be 90 degrees, so it will be pure extorted. It will move the eye around the anteroposterior axis outside. Extortion means to outside towards the temple, entorter toward the nose along the anteroposterior axis. And here again, all the muscles are removed except the inferior rectus muscle. We can see in the primary position how is the angle between the muscle and the visual axis. When the eye moves laterally, look at this, moves laterally, it will be the only depressor, depressing the eye or taking the eye down or inferior position. But when the eye is adducted, that will be extorted, so it will rotate the eye along the anteroposterior axis to the outside. The superior oblique muscle is completely different because it arises, yes, from the common tendinous ring behind, but it works parallel to the globe on the nasal side, and then it changes its direction by passing through the trochlea, and then it will be inserted behind the equator. So the superior oblique muscle, when it contracts, it will depress the globe, not elevate the globe. So it's called superior, but it will depress the globe when it acts. And when the globe is adducted, means the eye looks nasally 51 degree, the visual axis coincides with the line of pole of muscle, or with the orbital axis, or the axis of the muscle. So the superior oblique will be depressor. Though it's called superior, it will depress the globe. When the globe is abducted, when the eye looks laterally towards the temple, 39 degree, the visual axis and the superior oblique will make an angle of 90 degree. So the superior oblique goes only in torsion, which means rotating the globe along the anteroposterior axis towards the nose. Inward rotation or outward rotation. And this is the superior oblique after we removed all the muscle. Here is the anatomy is clear. The superior oblique comes from the common tendinous ring, goes parallel to the bone till the trochlea, then it changes its direction. And look at it, the insertion is behind the equator. So the superior oblique, when it contracts, it depresses the globe because it is behind the equator. قانون الروافع بتاع زمان اللي كنا بناخده، اي حاجه بتقسم الكره نصين، اي حاجه inserted anterior بترفع، حاجه inserted posterior بتنزل. فده معناه ان احنا زي قانون الروافع، وبنشوف الرفعه اللي بتتحط في الاوناش بيحط التقل فين، قدام او ورا، لغايه ما ينزل او يطلع الرفعه. هنا شايفين ان السوبيريور اوبليك depressor only depressor in adduction، يعني لما العين تبقى رايحه nasally the superior oblique will depress the globe. In the primary position, when the superior oblique contracts, it will abduct the globe. Then contraction more will intort the globe. Let's go to the inferior oblique muscle. It's the only muscle arising from the floor of the orbit. And when the globe is adducted, which means the eye looks nasally 51 degree, the visual axis coincides with the orbital axis or the axis of the muscle. So the inferior oblique acts as an elevator. And again, inferior oblique called inferior, but that does not bring the globe inferior, it takes the globe up, so it's elevator. And again, because it's inserted behind the equator. When the globe is abducted, when the eye looks laterally, the visual axis of the inferior oblique, and it will make 90 degree angle with the inferior oblique axis, so it will be extorted, or extorting the globe. This is again, all the muscles are removed, and this is the inferior oblique in the primary position in the middle. So look at the only elevator when adduction, when the eye looks nasally and I contract the inferior oblique, the eye will be pulled up. However, in abduction, when the eye looks laterally, it will be extorting the globe. Here is summary of extraocular muscle action. The first muscle is the medial rectus. It has only one action, which is adduction or moving the eye nasally toward the nose. The lateral rectus, when it contracts, it moves the eye laterally, which is called abduction. It has no secondary or tertiary action. The other muscles have primary action and secondary and tertiary action. The superior rectus, as we said, called superior, so it elevates. So its primary action is elevation. Secondary action is intorsion and adduction when it contracts. The inferior rectus is depressor, so it's called inferior muscle. It depresses the globe. In the primary action is depression, and we all know that the superior and inferior octave only depressor or elevated in abduction, when the eye looks lateral. And the secondary and tertiary action of the inferior rectus are extorsion and adduction. How about the superior oblique, as we call it? Superior oblique and inferior oblique. Though it's called superior, it depresses the globe. The inferior oblique elevates the globe, and we all know that because the insertion is behind the equator. The primary action of the superior oblique is intorsion. It intorts the globe. The primary action of the inferior oblique is extorsion. However, the secondary action is of the inferior oblique and the superior oblique are different from its name. Superior oblique will depress the globe, and inferior oblique will elevate the globe. The superior oblique will depress the globe when the eye looks nasally. So we call it muscle of going down the stairs. Why? Because while we are going down the stairs, we converge the eye. So the eye goes nasally, and then the superior oblique will depress the globe. So any paralysis of the superior oblique muscle will lead to double vision, and that's why some of the patients, when they have fourth nerve palsy or superior oblique palsy, they fall from the stairs because they see things double. So it's only depressor when the eye is adducted or looking towards the nose, and this happens while you are looking to downstairs and looking to a near object like the stairs. So you try to converge the eye and then look down. So this is the muscle of going down the stairs. And here's a very good summary in the picture. the superior, any superiors are intortors and the inferiors are extortors. Any recti are adductors, recti, and the obliques are abductors. So we have to put this in mind. The superior rectus and the superiors are intortors, superiors, all the superiors, superior rectus or superior oblique. Inferiors are extortors. It takes the eye to the outside. And the recti are adductors. They adduct the globe while they contract. The obliques, they abduct, they put the globe outside. How to test their action? By positioning the patient in the primary position, looking into the light, fixing the target, and at a very certain distance, like 50 centimeters, you have to test the muscles. And here's an example of how we test the muscle. You will see it in the video in a few minutes, but you can see here it's like two oblique lines crossing both eyes, and medial and lateral horizontal line. So the first test is to let the patient look up and out. So this is the superior rectus muscle. To look laterally towards the temple. So this is the lateral rectus testing. To look down and lateral, it's the inferior rectus testing. And to look medial or lateral, you are testing the lateral and medial rectus. So that's why when we have to test the eye, we can cover one eye and test each eye separately, and we call it 6 cardinal direction. Each eye has a 6 primary directions, 6 أساسيين يعني cardinal direction. In uniocular test, you cover one eye and you test each eye separately. For instance, the right eye, as you see here in the picture, when we tell the patient from the right eye, look to the right, so the right lateral rectus is pulling up the eye to the right. While he is in the right and tell him look up, so the right superior rectus will pull the eye up, because we said before that the superior rectus is the only elevator in abduction when the eye looks laterally. And again, when the eye is looking laterally, ask the patient to look down, so the inferior rectus is working. On the contrary, on the left side, we can see the same picture, but why we have 2 muscles on each side? Look at the right side. Right superior rectus when the patient look up and out. Why left inferior oblique? Because the left eye will move up and in the same time, because both eyes move together. So the right superior rectus, what are the muscle which is working with it from the other eye is the left inferior oblique, because we said that the inferior oblique will elevate the eye when you look nasally. So it works with the right superior rectus. How about the right lateral rectus? When the eye moves laterally, the left eye moves nasally. So the right lateral rectus will work with the left medial rectus. Looking out and down. In the right eye, out and down mean the right inferior rectus. How about the left eye? The left eye would move in and down, which is the left superior oblique. As we said, the superior oblique, when the eye looks in, it takes the globe down. The inferior oblique, when the eye looks in or nasally, it takes the globe up. And these are the 6 cardinal directions. How about the binocular thing? When we are testing binocular, we are testing up and down, superior and inferior. The patient looks up and looks down. Some of the books say we have 9 directions. They consider the primary position is one of the directions when the patient looks forward. But we have other books saying that we have 9. As we said, up and down, 2 more, plus the 6 cardinal directions. So we have 1 more direction, which is convergence. Both eyes can convert and look nasally in the same time during conversion. And this is the 9 cardinal, the 9 directions. It doesn't call cardinal. It is the 9 directions when we test the eye bilaterally. And here are the 9 directions. They consider sometimes the primary position, as we say, number 1. Where is number 2? Looking to the right. Looking to the right. So this is right lateral rectus and left medial rectus. And the third position is, look at the picture, numbers. When the eye is looking out, the right eye, ask the patient to look up. So this is up and out. So this is the right superior rectus and left inferior oblique. When the eye looks out and look down, so this is the right inferior rectus, and on the other side, the left superior oblique, and vice versa on the left side. So we have, as we said, bilaterally, we can have 8 direction plus convergence, we can do that. And this is a live picture Look at the picture in the middle. This is in the primary position, the patient looking forward with the pupillary light reflex in the center. We spoke about that in the last clinical round. This pupillary light reflex will define if the eyes are parallel. When the patient look up and down, we can see how they can look up and down, but this is not the cardinal direction. The cardinal direction starts from the upper left corner on the picture here. When the patient look to the right, so the right eye will look laterally by the right lateral rectus. When the eye is looking laterally, let the patient look up. So this is the right superior rectus. Look, the patient look down. This is the right inferior rectus. So the superior rectus will take the eye up. The inferior rectus will take the eye down. Let's go back to the primary position and go to the left eye. Look at the left eye. When the eye looks laterally, the picture in the right hand corner, in the middle, when the eye looks left, so the left eye will move to the left by the left lateral rectus. The eye looks up, left superior rectus. The eye looks down, left inferior rectus. How about looking nasally, like testing the right eye again? Look nasally. So when the right eye looks nasally, the left eye looks temporal. So they don't work together. And we all said if the eye looks to the nose, the elevation and depression by the obliques. So if you are looking to the nose by any eye, the right eye looking nasally, so what elevate the right eye is the inferior oblique. What depress the right eye is the superior oblique. The vice versa in the left eye. The left eye looks nasally or medially towards the nose. The left eye is looking nasally. Ask the patient to look up, so it's the inferior oblique. Look down, it's the superior oblique. And this is a couple of movies you can enjoy after that.
Extraocular.
Another movie, you will enjoy listening to this movie. And you can practice testing extraocular muscle with any of your friends or any of your colleagues or anybody at home. Thank you so much for your listening.